Good morning, everybody. Happy Thursday. Welcome back if you're joining us again for part 2 of our Net Zero webinar series, and welcome if this is your first time joining the Spray team for this great discussion around net zero, how to achieve those targets, how to start the foundational digital infrastructure that can make that progress smooth, and how to accomplish that through renewable energy microgrids. So it's a broad topic. We've split it into a 6-part series. You're coming in at part 2. If you missed part 1, there is a recording on YouTube, which we will share the link for that afterwards. So make sure to go check out part 1 as well. We'll catch you up to speed today on a little bit of what we discussed 2 weeks ago. And then our topic for today is quantifying net zero status. So the actual quantification part of it based on actual facility data. So we'll get to dive into a lot of the details there. So let's get started with some brief introductions. If this is your first time in the Spray team, I will get us kicked off with some introductions and then we can dive into the content. I'll start us out. My name is Kimberly Holcomb. I'm the Director of Marketing here at Spray. So this area of content and events and things like that is my favorite area. So I'm excited that you're joining us here today for this great conversation around net zero, and really just thrilled to continue hosting these bi-weekly and hope that you'll continue to join. Okay, I will hand it off to Nevin next for his intro.
Thank you, Kimberly. Hello, everyone. My name's Nevin Thomas. I'm an analytics software developer at Spray. So I've been working here for the past couple of months, and it's been a great journey. And the main area where I focus on is building tools by extracting data, processing it, and visualizing it, and finally providing insights on it. So that's mainly I work on, and that's about me. And thank you guys for joining in for the second round of the webinar. And I'll hand it off to Steve.
Yes. Hello, everybody. My name is Steve Ulrich. I am a software developer and architect here at Spray. Been with Spray for almost a decade now, but I've got 25 plus years of experience as a software engineer. Yeah, this is an exciting topic. I think we built quite a bit of functionality in this space, and we're excited to present it to you and really be able to help everybody out. And I think that's the best part of using software, is when it can help out good projects. So I'll hand it off now to Jackie.
Hi, everyone. I'm Jackie Ling, a project manager at Spray. From systems engineering to quality assurance, I've navigated various roles in this field. I'm excited to share the insights on achieving net zero with you. So let's get started.
I'm Danielle Mason, and I'm the product marketing intern here at Spray. I've been in this role for a couple months now, and I'm really enjoying it. I just kind of do everything from social media to getting the webinars all set up. And so, yeah, I'm pretty excited for today, for part 2 of this series. Now for Sunil.
Thank you, Danielle. And thank you, everyone, for joining again. I'm Sunil Chorian, the founder and CEO of Spray. I'm very excited to be with this team and also with all the attendees and getting this series going. We had a lot of fun with the previous one, and this was also kind of challenging for us to put together on short notice, but it's been a fun exercise, and I hope all of you will enjoy it as well. What we're going to talk about today is really about the quantification, the data collection, the analytics, the quantification that's actually necessary to achieve ambitious targets like net zero. So that's the detail that we are going to cover today. Just to make a connection to the previous webinar, let me go through a couple of slides just to refresh everyone's memory on that part. So that'll set the stage as we dive into more of the technical details today. Could you go to the next slide, please? All right. So why net zero? why is it? Why are we even talking about this topic, right? The fact of the matter is, today when we look at climate change, global warming issues like that, one of the key things that we have as a globally really acknowledged is that we need to hold global temperature rise to 1.5 degrees, which means CO2 emissions have to really come down, and it has to come down to net zero in about 3 decades. The chart that you see on the left-hand side shows how steep that curve is, right? It took us a long time to get where we are at. Sort of since industrialization, the past 300 years of CO2 emissions that we've been liberally, putting out into the atmosphere, we have to bring it down to net zero in about 30 years. So it's a tall order, but it's a doable one, we think. So it's not all doom and gloom. And as we will show, while initially it might appear to be a daunting task, if you have the proper infrastructure, I think we have all the tools we need to take action individually, as a homeowner or as a commercial business to actually make progress in this area. This webinar will actually show you how to have sort of specific targets, so you can actually keep an eye on the speedometer, if you will, as you actually engage in that journey. So what are the key things we're talking about? This applies to all industries, companies, communities, countries. A lot of them at all of these levels have net zero targets. Net zero offers a measurable and quantifiable path to decarbonization. That's really key. And that's sort of in comparison to some of the very well-meaning initiatives, and good initiatives, but things like CSR and ESG and all that, where they're more policy-driven and the practice, it's difficult to track and measure and whatnot. Unlike those, net zero can be directly measured. So that's a very key difference. And we'll show you how that pathway, what that pathway looks like. The next line might be a little controversial, where I say net zero is relatively straightforward. Well, that's speaking as a technologist, I'd say that it's relatively straightforward, but like most issues, they're not really just about technology, right? There are a lot of stakeholders, a lot of differing opinions, points of views on this. But what we'll focus on today is that with the right infrastructure, we can make it a lot easier for various stakeholders to actually see and understand what's going on and take proactive steps for us to get there. That's what we'll do. And that little chart at the bottom, just a little reminder of the Pareto principle. 80% of the results that you're looking for comes from about 20% of the work that you do. The other 80% is, goes up into thin air as efficiency losses. So our challenge here is to kind of connect up or identify those 20% of things that we can actually do that'll have the majority of impact on our journey to net zero. So now that we have a rough idea of what net zero is and why it matters, why microgrids? Why should microgrids, energy management systems, virtual power plants, all the things that we talk about, as technologies that are required for managing the energy infrastructure, how do they contribute to net zero? What's the intersection between the two? So we look at it from two perspectives. On the left-hand side, we talk about microgrid site services. Site service just means it's at an individual facility. It could be a building, it could be a campus, it could be a commercial, office building, an industrial site. It's that particular, the location where you're trying to optimize something. So that's where you start. And you may have many of these. If you have a fleet of 100 buildings, you got to start with one. And then you build up that portfolio to your 100. So that looks at the site services that are important. And on the right-hand side, you have the, what we're calling the cloud services aspect of the solution, which means each of these sites have to connect back up. And then the entire fleet of 100 you can actually see from a single location, or for example, from many locations, but you're now cloud synchronized. So all the systems, the portfolio access, you leverage cloud services to actually get there. Again, I think one of the underlying assumptions here is that you need edge of the system, intelligence at the edge of the system to actually facilitate stuff like this. You cannot really push data from every little thing that you're looking at up into the cloud and hope that somebody will take care of it for you. Not going to happen, right? So you need intelligence at the edge of the system. That's where I think the heavy lifting actually gets done. and then processed or managed data makes it to the cloud, where you can actually further organize and do analytics, optimization, planning. All of those stuff can actually happen using that data set. So those are the two things. The reason microgrids are important is because a microgrid really has to talk to things, right? You're connected to, PV inverters, you're talking to gensets, you're talking to the battery system, meters, breakers, protection relays, all the equipment, ancillaries, equipment that comes into play, switchgear, you name it. The microgrid control software has to be aware of all of that. You'll be connected to that. You'll be able to acquire data from wherever it's actually required. So essentially, once you can do that, you have the foundation for doing things like net zero already in place, right? So that's the key message here. So you can really leverage your energy management infrastructure to do all of the things on top. If you don't have that, you have a heavy lift, because what's the saying? It'll be very hard to make the rubber meet the road, right? So you don't have that last few meters of connectivity, and therefore everything looks great on paper, but you really cannot implement anything, and you can't see anything. So that's the difference in the connection. So once you have the proper digital infrastructure in place, it makes the rest of the stuff come together very easily. That's what we're actually going to see today. All right, this is my last slide to kind of set the stage. Just repeating what I generally described, the figure on the right-hand side really shows the layered digital infrastructure that really has to be thought of as the proper foundation for any initiative like this. The different layers are very important. The very bottom layer is where you talk to actual equipment, as I mentioned. The level above that is where the edge of the system intelligence resides. In this case, it's called a site controller. And think of it as some processing node at the edge of the grid where some software can run. It's actually doing the heavy lifting on the site. It is not just a data gateway. This requires the intelligence at that location to process gigabytes of data on a daily basis. There's a lot of data that's generated from these operational systems. In this case, the controller will also have a lot of intelligence, do specific things, which we'll touch on later. The level above that, those are the cloud services. Now you have cloud synchronized, the data is off the controller. So now you can actually process it, do all kinds of cool things with that, all the way up to adding in AI, ML capabilities, advanced optimization, a lot of things you can do. And then the very top layer is about connectivity to other entities, the service provider, the market operators, somebody else that might be doing just analytics type services. You have a range of capabilities that you can actually connect the system up to. So this layered approach is really what you need. And as you look at your own digital foundation for your energy infrastructure, keep this in mind and make sure that the requirements of the individual layers are actually addressed or acknowledged up front. It would be very difficult to actually bolt on these capabilities. They don't really go together very easily, no matter what people might say in general. So you have to have an architectural view that allows you to take it from the very bottom to the very top. And you might implement it in pieces, but the overall structure and the architecture should be accounted for from the very beginning. The picture on the left is more about the journey that all of us are on net zero. What it's basically pointing out is that designing and deploying systems has to happen at the proper level. If it's at a building or a campus, you're picking the location, you're picking the initial project, that has to be deployed. You monitor, control that system, operate, measure what's going on, manage the data, bring it into the proper analytics tools, bring it up, again, once you're around that circle to replicate and scale. Then you might say, I got to add my second building and my third building, and you go around that circle again. So you can have a very iterative process to actually deploy systems like this. That's the only way you're actually going to get to net zero. There is no silver bullet to actually get you there in one shot, right? So the two sides, the digital infrastructure and the process, are actually related with each other. And we're actually going to show you how we're going to take a spin around that circle today. Actually, Kimberly, back to you to get us to the next section of the presentation.
Thank you, Sunil, for setting the stage there, and hopefully that allowed everyone in the audience ability to kind of catch up to date of where we are talking today. So as Sunil mentioned, in that process, we're going to be focused on that data chain throughout the process today. We've set these the bold net zero goals. How do we quantify our current status and where we are in relationship to that goal? What are the necessary pieces or inputs that go into that? And then how do you continue to track that as you improve and continue those iterations of your system, improving your facilities, as Sunil mentioned. This next section is going to be focused on what those inputs are for quantifying net zero based on what data you're able to extract from those facility operations. Sunil, I'll hand it back to you for the methodology section. So this is where we're going to go over just kind of the mindset and the methodology behind what requirements we have for data and then what those flow into for the formulas and calculations for net zero.
What we'll look at here is a little bit of details on the types of data that are required to calculate the proper metrics as we proceed on this net zero journey. The 4 boxes at the top here, grid, loads, renewables, and storage, they kind of represent sort of the key types of equipment and systems that we'll be utilizing, right? The grid is just the electric utility that you're actually connected to. And of course, if you think about it, the electricity that we are consuming, that's a big part of our energy to do whatever it is that we do. When we walk into a room, flip a switch, we're using grid electricity most of the time. In that case, what data is actually required? We need to know what's happening at that point of common coupling or that grid interconnection point for that particular facility. So typically there'll be a meter of some kind there. Sometimes there are 2 and a breaker that allows you to separate from the grid if you're a larger facility. So there are some measurements that actually occur there. Active power, reactive power, the status of the breaker, frequency, voltage, things like that you need to pick up from that location. When you look at individual loads inside any facility, whether it's a home or a much larger facility, you have some sort of a switch gear or a circuit board that splits the circuits into multiple circuits. And if you want, you can actually put in what's called submetering to actually pick up the data from the different loads at whatever resolution you want, depending on your facility. It may just be one at the very top that says, this is my total load, or it might tell you I have 200 circuits and sub-circuits and whatnot, and I can measure that in quite a bit of detail. Renewables, wind, solar, those are typically the resources that come into play, with solar very often being the resource that you have locally, right? On some large campuses, it might be possible to have wind turbines, but usually they end up being remote somewhere else. Again, you want to know the production, but not only the production, you want to know the status. If you have a solar inverter, you might want to know, is my solar being curtailed? Is there an alarm on the thing? Is it actually producing temperature properly, or is the temperature too high and my efficiency has gone down? So there's data, there's a lot of data that these inverters actually collect and make available to you. So what you really want is to acquire that data appropriately. When it comes to storage systems, there are many different types of energy storage equipment, right? Everything from mechanical energy storage like a flywheel to lithium battery systems to flow batteries. So there's a range of technologies there, compressed air systems, so you name it. There are all kinds of energy storage possibilities. But there are some interesting characteristics of storage that makes them very interesting. Main thing is you can store energy in that, you can get it back when you need it. It doesn't really produce any energy by itself, right? It's just using energy from somewhere else, storing it for a period, and then making it available at a different time. So that brings you a lot of flexibility, and the optimization that you can do with it is quite significant. Now, that also means the amount of data that those things hold are quite high. It's as you can see just from the size of the list there, this is by no means a complete list, right? Steve showed you just the drop down, he will show you, the amount of data that the microgrid systems would actually collect. So the point is a lot of data in the system, and this doesn't even say anything about the ancillary systems that I was talking about, like switchgear and all that. A lot of data, our challenge is to acquire that data in a streamlined and smooth manner. So we have to have a model for the system and then make sure that the data is actually available to you. And if the data is properly collected and managed, then the calculations and all become much easier. So what are we supposed to calculate, right? So good news, bad news. Bad news first. Not all that bad. There's a lot of stuff that we need to know about. Everything from, when we say grid electricity, what's the carbon content of that grid electricity? The question, right? If I'm using natural gas, what happens there? Depending on the source of the natural gas or for example, coal, your CO2 content and your GHG footprint can actually vary. So you have to know a lot about your source fuel to be able to properly calculate the GHG impact. But in general terms, you can look at diesel, you can look at natural gas, if you have wind installed, stuff like that. You need to know information about those sources and the calculations related to that. So now the good news is, there are a lot of sources for the formulas to actually use. And in this particular case, we are actually showing an EPA calculator that allows you to say, if I burn 1 gallon of diesel, what's the carbon footprint? So we have a reliable source of data for those formulas, so we can actually incorporate them into our calculations. Okay. So we mentioned a few. Here are a few more. There's only one here that I want to call out. Well, the items that we have listed here: coal-based power plants. What's the carbon footprint of that? Grid electricity reduction through efficiency measures and solar. So that's really an offset calculation. If I replace my HVAC system with a more efficient one, my efficiency has gone up, and in that process, my carbon footprint has gone down. So there are specific formulas you can use to actually compare that against a baseline. Electricity consumed, that is just you can look at it from a very general or an average perspective. Some of the formulas that are used are based on in the US averages, right? It looks at the total electricity consumption across the entire country. It looks at the entire load and say, on average, how much electricity am I using? And then inside of that, the power production from large utility power plants. You can divide that and say, what's my average greenhouse gas footprint as a country, right? So there are some calculations like that. The one at the bottom that says CO2 content of grid electricity by location and time, that is actually a very interesting one. More recently, there are service providers that are looking at the source of power for grid electricity locationally. So here we are in Colorado, we have certain sources that we use. If you're in California, it'll be a different production sources that are primarily being used. So these service providers look at the production, and for a location and for a given time, they can actually estimate the carbon content of the electricity that's being delivered to you. So that's very interesting. So in this case, there is a service out there called What Time. They have this type of a service, and you can sign up for their APIs, and they'll give you every 5 minutes values for what's the estimated GHG content of electricity delivered at the region or the location that you're at. Now, suddenly you have options to say, oh, I have a battery. I can charge when the GHG content is low and discharge when the GHG content is high on grid electricity. And by shifting that demand based on that ratio, suddenly I'm able to lower my own carbon footprint, right? So, and it also helps the grid because you're actually utilizing, your load goes up when the carbon footprint is low. So it actually helps society as a whole as well when you're able to do that. So these are some of the more intelligent ways in which you can decide how to consume electricity, so you can make your journey to net zero more meaningful, and I think quantify it more accurately. But when you think about it, where is the data coming from? It's not coming from my facility. It's coming from some API in the cloud somewhere. But with the proper digital infrastructure, you can pull that information, combine them, do the calculations, and scale effectively.
Okay, perfect. Thank you, Sunil. That wrapped up a good setting the baseline for everyone here so that we're speaking in common terms around what inputs are required and needed for each of these calculations. And we are going to show you, starting from the very beginning now, what that looks like in a real life example. So in just a minute, we're going to look at real system operations or simulated system of a facility operations, the data that's available there, how that can be extracted through the API seamlessly. And like Sunil was saying, rather than having to bolt on top a net zero infrastructure, you can use that already existing infrastructure that you've established and that architecture for your data to then seamlessly extract that and run analytics so that you have visibility into your status today in regards to your target, and you have the tools needed to make those strategic decisions going forward. So a little bit of what we're about to cover throughout these demos. Just want to give you a snapshot because you're about to see a lot on the screen as Steve and Nevin take you through the demos. This will help kind of chart the path of where we're going. Once again, back to that process cycle that you can see there on the right, we're going to go through each of these stages. So first, we're going to look at how you connect that field equipment and gather the operations data for the net zero quantification from the site. So designing your system strategically, and then looking at, once it's designed as well, how that equipment's connected and how we're gathering that data. How you can access the data through the on-site intelligence through the site controllers. So you have a site controller that's monitoring, controlling your site already. That's everything on the site level, but it is the most in tune to all the data that's there on the site, and that is the point of access. And then rather than running the analytics there on site where you could cause issues with your site control, we're going to show you how you can use an external analytics engine to process the data, extracting it through the API. So that's where you'll run your net zero calculations, you'll trend the data, and we're excited to show you some of that through the analytics engine. So once again, moving around the circle there, after you've designed, deployed, monitoring, controlling it there on site, operating and measuring progress, then you can manage your data, report on that data, extract it, analyze and optimize, and then use those insights and that foresight to then look at how you're going to replicate this model and scale based on the infrastructure that's available to you. So that will allow you to decide how you want to start incrementally adding those resources to achieve your target. And it allows those system upgrades to be a lot more streamlined and easily accessible because you already have that infrastructure in place. And then as you make those system upgrade decisions, the net zero calculations are automatically repopulated because, like I said, that infrastructure is already there. So it's just continuing to look at that over iterations and using a staged approach to progress towards net zero. So that's the process that we're going to flow through today. I'm going to hand it to Steve first, who's going to talk at the site level, going to show you a configuration of a facility and talk about the control and monitoring capabilities there. So Steve, over to you.
Yes, thank you, Kimberly. Let me go ahead and share my screen. And I'm going to just kind of give you a brief introduction to what we're seeing here. So this is a test environment that we've set up. This is representing the actual wave controller that was in the stack that Sunil had shown you a picture of earlier. We're not talking to any facility, any real assets here. What we have behind the scenes is we've got an emulated environment. If I show that really quickly here. So what we've done is we've set up a site. It's a relatively small site. It's got a couple of assets provisioned and made available. So if we want to extend this out in the future, we can, but they're currently disabled. This is the emulator, which is simulating the actual real telemetry readings and the behavior of our facility. And then inside of the wave system, we have the same one-line representation that shows over here. The utility is connected at the top here, and Sunil was mentioning about the interconnect. So you can see we're currently importing about 568 kW to support our load. The load right now is it's a relatively good size load, 780 kW is currently in place. And we have one PV that's currently online. Like I said, we have the ability to extend this out for additional assets if we need to. But currently the ones that are online is just one load and one PV. There's some backup generation which isn't being used. And then we have some batteries that are in place. They're currently not being used either, and they're just about 80% state of charge. So what we're doing right now is we're just monitoring this system. the simulated environment. It's taking all the data, storing it into our system, into our database. And if I go to our dashboard screen, we can see kind of some basic on-site metrics and some data that's being captured here. This latest view, this is giving us kind of a graphical representation of what's happening with the system based off the different asset types. We've got the utility connection here, how much power flow is coming across that to support our load with the PV in place. And you can see here that we're not getting any production right now from our gens or our batteries. We also have a nice trend view, so you can see the data as it goes through the system. We've got a lot of other properties that can be plotted right now, but what we're looking at here is the green line is the utility flow across the PCC. The red line here is our load. So you can see that it's following the trend for how much load we have. PV production, what we're currently simulating is a profile that's kind of a typical 24-hour cycle, day in the life of. And so since we're at the middle of the day, right now it's pretty much flat. There's not a whole lot of real cloud or disturbances going on right now. So there's not a whole lot of deviation in our PV production. And one of the points that Sunil had made earlier was to talk about the types of data that we collect in our system. So if I just load up a representation of our types of data, Sunil was showing kind of a shorter list of some of the details about the different asset types and the different types of readings we have. But this is a more comprehensive list, and I think he had mentioned that I was going to show this. So you can see we've got a full list of on-site calculated metrics. This isn't doing the same level of GHG calculations, but it's a kind of more of an on-site calculation. We've got values here for the PVs that are in place, loads, batteries. So any one of the different assets and asset types, we're collecting an extensive list of telemetry readings, storing that in our database, and then we make this data available, synchronizing up to the cloud, and also available through our API access. And that's what Nevin is going to show here in 1 second. The process where we have taken all these readings, push it across to the cloud, made it available in our API, and then the analytics side is going to be doing the calculations with how to determine where you sit with the greenhouse gas and net zero reduction. So I'll go ahead and I'll hand this off to you, Nevin.
This analytics section, I'll be tagging with Sunil to go through the analytics engines where Kimberly had mentioned. So like as Steve mentioned, there's the Wave API where we could pull the raw readings, and the analytics engine would capture it and store it into its own database. So it can capture the historic readings and store the data. So in this UI, in the left-hand panel, we can see the raw readings we are capturing from the API. So this includes the PV, total active power, the load total active power, and this all comes from the wave. And along with that, the MOER is a value which comes from another web API called watt time signal. And I will now select the PV total active power. So now you can see the trend chart showing up for the total active power of the PV. And yeah, and moving on to the next, which is the process data. And in here, there are two drop-down options. One is to select the time range of what range do you want. And now it's selected to 1 hour. And in the drop-down of which process data to choose, it includes the energy consumed and energy contribution from PV and the MOER as well. And the process data is basically the regularized data of the raw readings every 5-minute interval. So I will just now show you the energy contribution from PV of a 1 hour time range. And as you can see on the right side, the trend chart, you can see the energy contribution from PV of a 1 hour time range. And next section includes the GHG calculator metrics. So in the first drop down, we have the list of metrics we are calculating, which includes the energy consumed, energy consumption from PV, along with the GHG content of grid electricity based on use average, GHG content of grid electricity based on MOER, GHG content of electricity based on the PV contribution. So these are the three metrics we are calculating. And when we select one of these, and as you can see on the right side, we can see the trend chart for the GHG content of grid electricity based on US average. So, and now I'll give it to Sunil, where you can explain the more behind the math of how this is being calculated.
All right. Thank you, Nevin. I'll start off by reinforcing the fact that the data that you're seeing, Nevin made it look very easy by saying I can drop down a list and there you go. But the fact is there's a lot that's happening behind the scenes, right? The source of the data, as Steve mentioned, it's actually originating in equipment somewhere. In this particular demo, it's actually originating in the emulator that Steve was talking about. We inject PV profiles and load profiles and all into the emulator. But when you deploy this in the field, you just redirect that reading to the actual field equipment. So inside Wave, when we say it's an SMA inverter that you're reading the data from, there's a particular make and model. It might say SMA Core 1, right? So there is a particular way in which you have to read that. The protocols, the technologies used to read that data is published by the manufacturer. Wave implements that particular interface, and you can actually pick up all of that rich data from the equipment. That's happening in the field. The emulator mimics exactly the same thing. So when you pick that make and model, the source data is exactly the same as what you would see in the field. So that data comes into Wave. That's processed, but Wave is a real-time controller. It's an energy management system for a facility. So that data then gets pushed to the cloud services, which is where Nevin is picking it up through the analytics module. So you're actually using that Wave API, pulling the data, it's actually here. And as Nevin mentioned, you have the raw data. Think of the three tabs on the left-hand side as the primary readings that are coming from Wave. And then you're actually doing something to process it and to organize it appropriately. You regularize it. In this case, we're regularizing it into 5-minute interval data, so you can actually compare apples to apples across the board. There are unit changes, all kinds of standardization, normalization that you have to do. The good thing is a good analytics package actually allows you to do things like that, while there might be variability in the data that's actually coming from the field. So once you organize the data appropriately, then the calculation of the metrics becomes much, much simpler. So now let's take a look at what we are looking at here. Nevin, can you just go ahead and turn on all the trends and then just zoom into the first one, the readings from Wave portion? Go ahead and turn on the other. Okay, they're all there. Great, thank you. So just go ahead and this is fine. Let's look at this view. So the chart on top, as we've already mentioned, comes from it's a 24-hour data from solar. It's a 1 day that's actually selected here. And you can see the choppiness and the type of cloud cover that you're seeing in the middle. The chart at the bottom, the one in green, is the actual demand at that particular facility. So if you look at it, this is over, let's see, it's over the same 24-hour period, right? So it's starting at midnight, and then as the night progresses, the load is actually going down. So the negative sign on that simply means that you're consuming that data. If the sign is positive, that means you're producing. So that's the difference between the positive and the negative sign convention here. So when the trend goes up, on that green line, that means your load is actually going down, right? So it increases during the night, and then morning comes around, and then it slowly starts increasing. And you can see around 9 o'clock, it's a certain load. By midday, your load is maximum. In the afternoon, it's going down a little bit, evening profile, something like that, until you end up roughly where you are at the beginning at midnight the next night. So the advantage here is that if you know the profile of your facility, we can take data like this and actually inject it into the emulator, and you can start planning around what actions can you take, what might it look like. You can look at different solar data profiles. We are using solar data from public sources where you can download these data sets for all kinds of days, cloudy days, clear days, winter days, summer days. And you can make measurements at your own site. If you have solar on the rooftop, you can actually take that historical data. And the advantage with the analytics module is it doesn't matter what your source data looks like. You may have hourly data, you may have 1 second data. As you regularize it inside analytics, you either backfill or extrapolate or do the right things to organize the data in such a way that you can compare apples to apples. So that's what this one looks like. Nevin, can you turn off load and PV and just zoom into more? Thank you. Yeah, when he turned off the other two because of the scaling, this just popped up only because the y-axis on for more was very small, right? You can see that it's varying between about 0.3 and 0.55, and the other numbers are much larger. That's why it looked like a flat line in the previous view. So these data points correspond to exactly the time frame that we were looking at. And as Nevin already mentioned, this is the marginal emissions data from what time collected through a web API and plotted for the same time period. So we can actually, they publish data every 5 minutes with a forward look, I believe, for about, I think it's 7 days. So that's a forecast, but the current situation is an estimate based on public data that they have available to them. And so essentially, this tells you how the carbon content of your grid electricity is varying over time. So if you were to take one look at this and say, oh, my carbon content is really low and that graph is low, somewhere in the middle of the night on the right-hand side, that's a good time for me to charge my battery, for example. So if I do that, I'm charging my battery with grid electricity, but at a low carbon period. On the other hand, if you look at that spike at the top, you may not want to charge at that point because you have a very high level of carbon in the utility grid, in the grid supplied electricity, and at that time you may actually discharge your battery to make sure that you're consuming as little from the utility as you can. So that's the strategy that you can actually use. Normally, you wouldn't know this at your facility. You have no idea what your grid electricity is made up of. With information like this, you can make more intelligent decisions at the facility. And effectively, what's happening is, without doing anything else, just by knowing this information, you can reduce the average carbon footprint over some time period. In this case, we're looking at a 1-day time period, but it could be 1 month, it could be 1 year. You pick your time frame, and then essentially you can plan towards that. So now that you can see things like this, you have a much more you're empowered to take more proactive steps to actually hit your net zero goals. And then the fact is, every time these things happen, you can see what's going on. So now let's take a look at those types of actions. Nevin, can you go down to the second trend here, the one where you have process data? Let's open that up a little bit. Yeah. Let's take a look at. Let's start. Okay, so this one we are looking at the energy contribution from PV. What you're zooming in here, right? You're looking at a 1 hour time period, and the data has been sort of regularized in 5-minute increments. So that's just to make sure that all the calculations are actually aligned here. So now you can actually see this. You can go ahead and turn on the energy consumed, Nevin. Yeah. So now you're seeing two charts. The chart in green is the energy that you're actually consuming, and the one below is what's actually coming from PV. So what PV normally does is to actually offset whatever it is you're consuming from the grid. So if I'm pulling 100 from the grid and I have 20 coming from PV, net, I am only using 80 from the grid. And so now I can reduce my carbon footprint. So renewable energy sources are a direct means to offset carbon from any other source, right? Typically, the grid is where you're actually offsetting that from. So now you can actually see what's going on a pretty fine, granularity or time steps. You can make decisions there. Now go ahead and turn on the more one and turn off the other two. So, I wanted to turn that off, the other two, so the scale would actually show up, but exact same thing. So you're pre-processing the data to align everything here. That's the only thing. This is actually the previous trend we were showing was over a 24-hour period. This one, you just zoomed into that 1-hour period so you can actually see it at a higher resolution. That's the only thing that's been done. It's exactly the same data. Okay, now let's go to some calculations. So now comes the fun part. So I have all my foundational data in place, and now we can actually go and take a look at the GHG metrics that we are actually calculating. So there are several things that you can see here. Let's turn on the first one, energy consumed, Nevin, and turn off everything else. Yeah. So from any energy consumer's point of view, it begins with the energy you're actually consuming for your own operations. You walk into a room, you flip a switch to turn the light on, you're consuming that energy. Normally, nobody thinks about where it came from. You take that for granted, so long as you're in a mature grid situation. The second thing, go ahead and turn on the next one, Nevin, the energy contribution from PV. So this shows the energy contribution from PV. So these are the basic calculations of what's going on. Now let's go ahead and look at the GHG content of grid electricity based on more. Right? Okay, so now the blue line we are looking at, a metric calculation was actually done, which is to say, if this is the amount of grid electricity that I'm consuming, I can actually go in and say, what is my carbon content? So by knowing that marginal emissions rate, I do the calculation and I have a value that I get here. The unit of this is kilograms CO2e per kilowatt hour. Right, so that's the unit that you're actually using here. So it tells you can simply multiply that value by the electricity you're consuming, and you get this number, right? So it's no longer electricity. Now you're actually looking at, I think in this case it's plotted as grams of CO2e. That's why you have a high number on the y-axis as saying 25K. That's 25,000 grams of CO2e per, your, total consumption here. So that tells you right there. In this case, you're looking at CO2 as the primary GHG contributor. The line at the very bottom that looks flat, I think that's a more line. We can probably ignore that one for now. Let's now shift the calculation to the next thing that we want to know. So go to the next line there. Yeah, that one. So the GHG content of electricity consumed every 5 minutes, less what came from PV. Since PV is fully renewable, we're just removing that from the electricity that's being consumed, not what the electricity meter is saying. The utility meter will go down because you're producing your own electricity. And then now you're looking at the CO2e contribution from the net electricity that you're consuming from the grid. So it goes down because you've actually added PV to that. And based on the solar production profile, that value goes down. Same units. It's actually using grams of CO2e per kilowatt hour to actually show this number. Let's turn on the next one here with okay, what Nevin just turned on is the GHG content of grid electricity based on a US average. So now you can actually see a couple of things. What is the US average? What does the US average look like? Those are published numbers, but that's annualized across the country and whatnot. But based on that, you see a certain number. So that gives you a comparison to how everybody else is doing in general. And then the line with the PV offset shows you how you are doing right now, right? So this gives you a way to, this is your speedometer, right? You're actually saying, how am I doing right now? So now let's try a couple of scenarios here. Nevin, can you switch out of this view and let's go look at your drop downs there? Yeah. Let's just say that you are doubling your PV. You heard Steve say that you have the ability to increase the PV and actually redeploy the system again. So let's just say that you did that in the background. So in this case, we collected some of that information in the historian, so it's easier to kind of demonstrate pretty quickly. But the data will come over time. If you add PV, you don't instantly get this data. It takes I know hours, days, weeks, months for the effect to show up. But here, what just happened is that we just activated another PV array that's very similar to the first one. So your production is roughly the same. But what you can see on the left-hand side, the previous one was up in the 2025 level. The value of the GAG contribution has suddenly jumped down. Nevin, let's go and do the same thing. Activate another couple of arrays. So go to the PV4 case. Same calculation. You have more PV now, and we're going to look at that. And now you can start to see something much more interesting. So now you see that that line is actually crossing the zero line there. So what that means is that you have excess production that you can actually consume. So you have set the line there, and that crossing that zero line is when you're actually hitting net zero. And in fact, on the far right of this thing, you're actually net positive because you have more production than you can consume. Now comes interesting problems, meaning your utility may or may not allow you to export to grid. They may allow you to export to grid, but they won't pay you anything for it or very low numbers for it. So suddenly you're in a situation where you're saying, I don't want to export this to the grid. Some utilities will restrict you. They'll say you are not allowed to export to the grid. So you'll have to self-consume depending on where you are, and a lot of other factors come into play there. Regardless, remember the fact that you have a very intelligent underlying energy management system sitting there, right? That can do things for you and say, no problem. If those are the interconnection rules, we'll satisfy those, from the get-go. So you don't have to, worry about how to satisfy that. The underlying infrastructure already allows you to do that. So I think with that, I'm actually going to hand this back to Steve to actually show us what you do in that case through the control software to use your equipment more intelligently and then scale the system from there. So, Steve?
Yes, thank you, Sunil. Again, this is the same configuration. What I did while Sunil was talking here, he talked about how you can, show the calculations for whenever you bring on more generation with the PVs. So what I did is I turned on as if we had connected up these next couple PVs in the system. And currently the profiles on these is still running at a low rate, but I basically extended out my system here very quickly, very easily with the tool set and the testing that we have available. I also changed my state of charge of my batteries here, so it represents a sort of a low state of charge of the system. Now, what we can do if so since we're now at a point, one other thing I want to point out, I also decreased our load on the system down to about 75 kW. So what this means with our, it's about 300 or so, or no, it looks like it's a little bit less than about 200 kW of PV production. We now have an excess amount of PV, and as Sunil was just mentioning, we're currently exporting to the grid, and based off of all the rules for your facility, that may not be the decision that you want to do, and you want to actually do something about taking this PV and you want to actually store this into your batteries in preparation for when nighttime comes. Then you can actually use that PV production, shift it over to now being inside of your batteries. So if I change my mode here from just monitoring to now actually in a control mode, and then if I go to, we've got a control, let me go back over here to this view. We've got a set of controls in our system that could be enabled and turned on as needed. Typically, we run a lot of these simultaneously. In this particular case, I'm just going to run the SOC management control, and I'm going to start this up. And as soon as I start it up, what it's going to do is it's going to look at the current state of the system. It's going to pick up on the fact that there is two generators that are available, two batteries that are available that need to get charged up. And it's going to start using that excess PV production, and it's going to start pushing that into the actual batteries. There's a number of settings that we have available for how it should actually do the calculation or the charging of those batteries. I've got selected right now the excess solar charging, but there's a couple of other ones here that we could pick, you know, if we want to use all sources or restrictions based off of other conditions. So that just kind of gives a brief example, one case of how you want to run this. What you could also do is we can also go into our scheduling system, and we could use our schedules to also do the same thing. And you could actually schedule that for a given period of time throughout the day, or repeat repetitively every day at a given time. So you can actually schedule that same action. Now, and that's one way, if you've already kind of predetermined and pre-designed that you want to provision your system, how you can extend this out and use it in our controls. But if you actually go into a situation where you actually want to extend out, you know, like in this case, we've got 4 PVs available and 2 batteries. If you want to actually represent a, you know, more extensions to actually see, okay, if I add on more renewables to my mix, then we can start off in our configuration tool, and I can go back to our configuration list and pick a different starting model here. And I can actually now configure our system to, like in this particular case, it's got a total of 20 PVs that I can extend it out to. So if I turn all of these on and I redeploy the system, now it's going to actually have a representation for all these additional renewables. And the analytics, the data that's captured on site in the controller is going to also be available through our APIs. So the analytics module, it can pick up on this new changed configuration that now has an additional set of renewable assets, and can adjust now all of its calculations, recalculate it based off of the extra capacity, the extra amount of greenhouse gas reduction you can have in the system. So with that, I think I'm going to go ahead and return the control back over to you, Sunil.
Yeah, I think you saw the whole chain of how you go from configuring, deploying, getting the data available into analytics, you know, the types of calculations that you can do there. I just want to reinforce the last point that Steve made, that once the system is configured appropriately, you can scale endlessly, meaning that's really the part, the job of the software. Right? You're getting all of that as a side effect than anything else. So I don't have anything else to add there. I'll actually hand this back to Kimberly to kind of wrap this up.
Thank you so much, Steve and Nevin and Sunil, for going to all the details there. I hope that was really helpful for you guys to see that. We're running a little short on time, so I'm going to briefly go through these key takeaways for you all, and then talk about what's coming next. But this will also be available, this slide deck and this recording, in the coming week. So if you need to drop right on the top of the hour, totally understand. Throughout the conversation today, you've, I hope, have heard the continued thread of the necessity of having a strong, powerful digital energy infrastructure in place when you're beginning and charting your net zero journey, or wherever you are in that journey, whether you already have that in place and you're looking to further optimize it, or if you're needing to start with that first foundational infrastructure. So as you plan for net zero, putting that right infrastructure in place is number one. It can help you to establish that baseline, and then continue to measure your current status, analyze it, standardize, and then continue to scale. As you continue to scale, we recommend using a staged approach to achieve those net zero targets. We talked a little bit about that today, how that continued, that flywheel approach that we talked about, from design and deploying all the way through monitoring your system, operating, capturing that data, extracting it, analyzing it, and then continuing to replicate and scale. That is enables you to do that efficiently and effectively, and in a seamless way as you continue to deploy new projects, increase your efficiency, and hopefully you're able to also use a tool like Wave to streamline that process from configuration all the way through operation and optimizing. Speaking of Wave, and you saw a little sneak peek today on the analytics module as well, but the platforms and tools that you choose to implement are really crucial here. It's really important that, I think Sunil mentioned this a little bit at the beginning, but as multiple stakeholders are approaching this problem together, and this may be, you know, an organization-wide goal for you, or you might be a facility operator that this is a goal of yours, or whatever the case is. You know, this is net zero is a common topic, even, you know, worldwide and for countries as a whole. And so these siloed projects, that if those are not showcased to an ability where you're able to make those strategic decisions together, you will not be building that momentum that's necessary. So the proper platforms in place, and then publishing and those quantifiable goals and attainable results is really important as well, to verify that you are well on your way to achieving net zero. And this infrastructure and that clean, seamless way of demonstrating the net zero target that you're pursuing, and the reporting on it and having those analytics and calculations in place really builds trust across all stakeholders and allows you to celebrate those wins and that progress together. We've talked a little bit about the data today, and so this is my last parting thought. As our team was talking about this internally, we're using the analogy of, you know, if net zero is your end destination, the way that you are tracking your progress there, routing your path, is really crucial to success. And so we talked about the analogy of a net zero speedometer or odometer, and really keeping your eye on that as you are making improvements, to continue the analogy, if you're increasing the performance of your vehicle or rerouting your path, or charting your path from the beginning. Just having that speedometer and odometer always in the forefront of your mind allows you to make those strategic decisions and continue to accelerate, and your ETA, your estimated time of arrival, continue to go down. I want to give a little sneak peek to some upcoming sessions that we have. We've already gone over that last one I mentioned, the introduction to net zero. Go take a look at that recording if you haven't already, and feel free to reach out to our team if you have any questions or want to continue the discussion more one-on-one. Today we covered net zero metrics. In 2 weeks, we are going to be diving into demand limiting, and Jackie's going to be leading the charge on that conversation. That's one of her areas of expertise, so I'm really excited for that and hope that you'll join us there. Overall, it's one thing to want to accomplish net zero, to talk about it, for that to be the target, and that to be the goal where you want to land. This chart over here on the right that shows that curved line of additional values that can be captured along the way, I think really is one of the key points to remember, that net zero might be the target, but there are so many values that can be captured along the way as you continue to improve your system and operate more efficiently, effectively, and have that intelligence available to be able to capture multiple value streams as you're also approaching net zero and making your way there. So that's kind of that automatic, consistent benefit, but there's additional benefits open and available as well. Change over to the last slide here and just extend a thank you to everyone that participated today, that joined us in this conversation. Thank you, Spray team, for putting this all together. Or have any questions that you would like to discuss with one of our team members, feel free to reach out to this email here as well, or give that number a call, and we'd be happy to continue the conversation with you personally. Otherwise, thank you for tuning in today, and we will see you in 2 weeks on March 28th.